Welcome to the exploration of cross-equatorial northerly surges. We'll dive into how these surges behave under different ENSO and MJO phases, a fascinating study by Qoosaku Moteki from JAMSTEC. For more detailed insights, you can refer to the article in Scientific Reports. Cross-equatorial northerly surges, or CENs, are strong winds observed over the Java Sea from December to March. First introduced by Hattori et al. In 2011, they're essentially cold surges extending from Eurasia, influencing rainfall and air mass modification over regions like Borneo and Java. In our study, we investigated 6 observed CENs events from the YMCCSO 2021 campaign. Observations revealed that the thickness of northerly layers varied due to Southern Hemisphere low-pressure anomalies. Statistically, 80% of these events happened in January-February, especially during La Niña years, with notable occurrences in MJO phases 4 to 7. Our research focuses on examining the thickness and thermal characteristics of northerly flows, identifying favorable conditions for their occurrence, and understanding their role in enhancing rainfall. During the YMCSO 2021, we carried out enhanced radiosonde launches 4 times a day at Pangkal Pinang and Soekarno-Hatta airports, documenting significant rainfall events over Java Island during this 60-day period. Examining the environmental conditions of 6 observed CENs events, we noticed variations influenced by whether cold surges were present. The MJO phases played a role in these conditions, ranging from inactive to active across different phases. Identification of these CENs events relied on detecting northerly winds reaching or exceeding 5 meters per second. Additionally, temperature drops were noted just before the onset of these events, providing crucial insights into their development. Regarding MJO phases and amplitudes, the MJO moved from phase 3 to 8 within our study period. Significant activity was observed particularly in phases 6 and 7, during which all 6 CENs events occurred. During these events, rainfall distribution highlighted enhanced precipitation near Java Island. Concurrently, low-pressure systems were detected south of Java, indicating a complex interaction between atmospheric elements. One of our key findings is the structure of CENs, where the thickness of northerly flows was observed, extending from the surface up to between 800 and 400 hPa. This indicates a robust vertical distribution. Additionally, we noted temperature anomalies associated with these surges. Specifically, there were cold anomalies ranging from -0.5 to -1.5 Kelvin. These deviations are essential in understanding the impact of these atmospheric events. The pressure gradients also played a pivotal role. We identified high-pressure anomalies in the Northern Hemisphere and low-pressure anomalies in the Southern Hemisphere, creating a significant southward pressure gradient. In our analysis of CENs occurrences over 64 years, we found variability across ENSO phases. For instance, occurrences were most frequent during La Niña years, with specific variations throughout December to March. This data helps us comprehend how ENSO phases influence CENs events. Our second key finding highlights the occurrence conditions for these surges. Notably, 80% took place between January and February, with a higher frequency during La Niña years. The duration typically ranged from 1 to 4 days, extending up to 10 in some cases, primarily during active MJO phases 6 and 7. Our third key finding focuses on CENs statistics. We observed enhanced rainfall south of Java and identified zonal cold anomalies across the equator. The ascending motion noticed at 10 degrees and 100 degrees E further elucidates the meridional and zonal atmospheric structures during these events. In summary, we investigated 6 observed CENs events during YMCCSO 2021 and found variations in northerly layer thickness. Low-pressure anomalies in the Southern Hemisphere were crucial, and 80% of events occurred from January to February, particularly during La Niña years. Additionally, 35% of events aligned with MJO phases 4 to 5 and 52% with phases 6. This is from the 2024 paper by Qoosaku Moteki. Thank you.